In this video, I want to put everything together and analyze what happens at the beginning, in the middle, and at the end of a bicep curl. So let's start out with, let's start at the beginning. So, beginning of the bicep curl, you've got some dumbbell down here. It's got some weight. That weight is offset from the elbow joint at some moment arm, like this. And your bicep muscles are going to produce some amount of force like this. And that force is going to cause your elbow to flex. It's going to cause a torque that will make your elbow have a tendency to flex. And that torque will oppose the torque created by the dumbbell. So, at the beginning, the fiber length of the bicep muscles is going to be relatively long, correct? Because it's like they're stretched out. The fiber velocity is going to be 0 because they're not moving anywhere. The muscle moment arm, what was that again? That was this. Maybe I can zoom in so you can see. That was this distance, the perpendicular distance from the direction the muscle force is going to the elbow joint. So that is, let's say, small, right? Relatively small. Now, what's the weight force? Well, the weight force is just gravity times the mass of the weight. Let's continue with what we had earlier. Let's say it was a 25-pound dumbbell. And immediately we can tell that this whatever is in this column isn't going to change if we're making a table here. It's not going to change because the gravity is not going to change, and so the weight of the dumbbell is just going to stay the same. Now, what's the moment arm of the dumbbell? Well, I already drew it. It's right here, and that's going to be relatively small compared to what's going to happen later. Now, in the middle of the dumbbell curl, what happens? Well, if we go along our table here, the muscle fibers get shorter. The fiber velocity goes up, right? Because we're actively contracting the muscle, so it's going to be above 0. The muscle moment arm, this distance, gets bigger. The weight is moved to here. Oops. But the weight force is still going to be 25 pounds because clearly the dumbbell did not get any bigger. And the weight moment arm, well, what is that again? That's now this distance. Notice how it's gotten much bigger. And then finally we can think about what happens at the end of the dumbbell curl. Now, the dumbbell has moved back to about here. And something interesting to note, the dumbbell, still weighs 25 pounds. No problem. The moment arm has gone down because now it's this distance, right? Instead of in the middle, it was this distance. So now it's small again. The muscle fibers have gotten even shorter, right? Because this distance is smaller than the length of the muscle here. So notice how the muscle fibers go. Maybe right, very short. Fiber velocity still kind of positive. We'll say positive. Maybe this should have been a positive as well. Just a positive. So what does that mean? Well, if the fiber velocity is positive, we know the muscle's force production capability is going to be somewhat smaller than if it was not moving. This is why, by the way, if you're lifting a very heavy weight, you tend to move it very slowly because you are deviating only very slightly from your maximum isometric force with regards to fiber velocity. What about the muscle moment arm? Well, I think it's slightly smaller again because previously it was this distance right here. And then now at the end, it's maybe a little smaller. It's now maybe that distance. Maybe we could say medium. It's not quite as small as at the beginning. Now, this is not something, this kind of analysis is not something that's, I'm going to ask you to do completely from scratch. I might have you walk through it on a problem set. But this gives us some really, really good insights into what is going to happen at the different points in a bicep curl. So it certainly seems like at the beginning of the bicep curl, when this is most difficult, probably the dominant factor is, well, which of these things are going to be working against us? What's going to make this difficult? Well, the small moment arm of the weight will make it easier, right? Because the weight is inducing less torque like this. The weight force doesn't change, so we don't have to worry about that. The muscle moment arm is small. That's probably a big factor. The fiber velocity is 0, which should help us because we're at a good point on the force velocity curve. But the muscle fibers might be too long. So we could say that the reason the bicep curl is difficult at the beginning is, number one, the fiber length is relatively long, and number two, maybe more importantly, the moment arm of the muscle, this distance right here, is very small. The bicep curl gets easier in the middle of the exercise, like right here, because the muscle fibers are getting shorter and they're getting to a more optimal point on the muscle fiber, on the force length relationship. So maybe you start out here and you know, in the middle of the bicep curl, you're here or here. That's a better place to be. You can produce more force. And perhaps also importantly, the moment arm of the muscle is bigger, meaning for a given amount of force, you produce more torque. Ironically, the moment arm of the weight is actually bigger, and so that's working against you. And so is the fact that you have a non-zero fiber velocity, because if we redraw a little sketch of the force velocity curve, maybe we moved from here at the beginning of the bicep curl to here in the middle. You'll find in the weight room, if you try and do bicep curls really fast, you will not be able to do as much weight because now you're operating down here. So you're producing a smaller amount of force. That smaller amount of force is getting multiplied by the same moment arm and is creating a smaller torque. And then at the end of the bicep curl, to round things out, way up here, well, this is very easy. And the reason it gets very easy up here likely has to do with the fact that the muscle moment arm is still relatively, large or medium-sized, and the weight moment arm is now small. Certainly the fiber length isn't helping you out because when you're up here, your muscle fiber length is relatively short. But the fact that you've decreased the moment arm of the weight to be like this, that is where the major benefits, or that's what probably the biggest influence on why this exercise is easiest when you've got the barbell or the dumbbell almost all the way up. So this might be a lot to take in all at once. I'd encourage you to maybe rewatch this video if some parts moved a little too quickly. But this is a lens with which we can use to understand force length, force velocity, and moment arms of both the force we're acting against, usually some kind of weight, and the moment arm of the muscle itself to get an idea of when is an exercise going to be difficult, when is an exercise going to be easy, what is the limiting factor of an exercise going to be. So hopefully this helped you see how all of this stuff comes together to determine the difficulty or the challenge of a particular exercise.